And ladies and gentlemen, welcome back to Simpkins Physics Corner. I've missed you. I'm so excited to be back this week. I'm out of my quarantine. All right, I can come back and join y'all finally. I'm feeling great. Thanks for asking. Doing fine. Just want to check in with y'all. I got a couple of questions about these concept builders. So let me get to it here. I'm just going straight wizard level on you, all right? Because if you can do the wizard ones, then you can pretty much do any of them. Now what I'm going to do is I'm going to snip this over here real quick so I can do some writing on there, and we'll talk about ranking these guys. So we're talking about Newton's laws. We've been doing Newton's second law this past week with F equals ma. We know what that means is that for every unbalanced force, an object is going to be caused to accelerate. And so let's go ahead and draw a little something on here. F equals ma. Now this one says rank the net force, use 1 for the most negative and 8 for the most positive. That's it? We're just ranking force. Okay, well, check this one out. This is pretty straightforward. So number 1 would be the most negative. So let's go ahead and see which one has the most arrows going to the left. All right, well, let's see. Let's wear our contenders here. We got this one, and if you look, that's 4 and 4. That's 8 newtons to the left total. But this guy over here, that one has 10 newtons to the left. All right, anything else giving it a run for its money? Not really. Okay, so that means this is the most negative, and this is the second most negative. Let's keep going. Let's look for any other forces that have some to the left at all. It looks like this one has 6 to the left and 2 to the right. The overall, or the net force, would be negative 4 newtons there. So that would be number 3. What else even has forces to the left? Now, this one has some force to the left, but you notice there's more force to the right. So its net force would be positive. All right, but then the next one, I guess, would be this guy, has 4 to the left and 4 to the right. That overall force they're going to cancel out. It's going to be 0. And so that is going to be ranked number 4 as we rank these up on the number line. Then we keep going. We're looking for positive forces. So this one has a total of positive 10 newtons, or 8 and 2 to the right. This one has a total of positive 6 newtons. This one's got a total of positive 2 newtons. And this one's got a total of positive 8 newtons. So we just got to work our way through that. So let's see. It says number 8 is the most positive, right? So number 8 would be this one, the most positive. And then this one would be number 7. And this one would be number 6. And this one would be number 5. So as we look at these, we went all the way. This one has negative 10 newtons. We went all the way from negative 10. And then number 2 was this one for negative 8. And then we had number 3 here was for negative 4. And you can see how as we're ranking these, we're doing it exactly as they asked us to. We're doing it with the most negative as the lower numbers and the most positive as the higher numbers. So we keep going with this one. Number 5 was positive 2. Down here, that one was positive 6. Then we had a positive 8, and we had a positive 10. So for this one, when it asks you to rank the net force, guys, all you have to do is look at the arrows, all right? Which one has the most force going to the left? If they're opposite directions, they're going to cancel. If they're the same direction, they're going to add up. And that's it. So if you can do a wizard level one with 8 of them to rank them, you should be good to go. So let's go back to the main menu. There was another task that was net force ranking tasks. There was another task that was assigned to you guys. Let me pull that one up here for us. All right. And I believe that one right here was balanced versus unbalanced forces. So I'm just going to go over here to Google here and say balanced versus unbalanced, and it should just pull up the little concept builder for me here. Interactive, is it that one? Let's see. Concept builder. Here we go. Let's look at this second one. All right, here it is. And we're going to go straight wizard level again, all right, because I think it's just going to add more stuff for you. So balanced and unbalanced forces. Let's see what we got going on here. All right. There's a couple of different types of questions. So why don't we just do one of each of these? We'll do apprentice level 1 here. All right, this one says the diagram represents the forces acting on a rightward moving object. Okay, and then it says, is it speeding up, slowing down, or at a constant speed motion? Now, you got to read the directions, guys, because it says you're moving to the right. All right, that means something. So it says we're already moving to the right. So let me get back to my slides here. We'll drop a couple notes in for us for this first set of problems. All right, now, Newton's second law, F equals ma, says that you're going to accelerate in the direction of the net force. Now, just looking at this diagram, there's no force to the right at all. So the net force is negative. You can call it negative F, or you can say the net force is that way, is to the left, right? And so if we're moving to the right, you can say we're moving right, because that's what the problem said. It said a rightward moving object. If you're going right, but experiencing a force to the left, guess what? You're going to slow down, okay? So that's how you pick the first answer there. You consider which way am I going and which way is the biggest force. If the biggest force is the way I'm going, then I'm going to speed up. If the forces are balanced, I'm going to stay at a constant speed because there's no reason to change what I'm doing if the forces are balanced. And if the biggest force is the opposite direction of the way I'm moving, then it's going to be a slow down one. All right. And then is the object experiencing balanced or unbalanced forces? Well, of course, there's nothing to balance out the leftward force, so it's unbalanced. So if I come back to my concept builder here, I say we're slowing down. We have unbalanced forces, and we're one step closer to our trophy for that one. Now, I guess there is a little bit of variety here, so let's go to the next one, master level. All right, let's see what we got going on for this one. Now, are there different types of questions? So this one says we're moving down, right? So if you're moving down, the biggest force is down. That means you're speeding up. Why? You accelerate in the direction of the largest force. If we're already moving down and we have a bigger force down, we're going to move down. We're going to move faster down. But it is unbalanced because those forces are not the same size. So that one was just like the first set. Let's see if there's some different types of questions. Here we go. Got some graphs. The motion of a leftward moving object is represented by a position time graph. Consider the positive direction to be to the right. All right, is it speeding up, slowing down, or a constant speed motion? So maybe this one was giving you guys some trouble because we got some graph throwbacks here. All right, it's been a minute since we've seen some graphs of motion, but we can't forget all this beautiful physics that we learned already this year. So let me drop this in here for you. All right, if you're moving left, all right, and it's curvy like this, remember what we did. I call it the pencil trick. Now, I can't do a digital pencil, but what I said is you can lay your writing utensil, or you can imagine a straight line along the edge of your graph. So, well, this is what I mean. Like right here, it's very steep. Oh, all right, it's very steep, and it's negative, right? But then here, it's less steep. And remember that steepness of a position time graph's slope tells us about the speed, more particularly the velocity. But this shows that you're slowing down because you're getting less and less steep. So that's a slowing down. And if you are slowing down, if the graph is curvy, that's because you are accelerating. And that means if you are accelerating, it means you must have unbalanced forces, all right? Because unbalanced forces cause an object to accelerate. So you're slowing down and you are experiencing unbalanced forces, and we cop another star for that one. Pretty nice. Is there a different type of problem? Okay, here we go again. Now this one, you notice the graph is straight. A straight graph means constant speed. You got it. And if you're moving at a constant speed, the forces must be balanced, all right? Because if there is no unbalanced force, there is no reason to change what you are doing. So let's cop another star for data way right there. All right, I'm not going to do, let's do one more because I'm not going to do the whole set for you guys, right? But this one's moving to the right. Now, remember these dot diagrams. This is a throwback to Hansel and Gretel here, right? The dots are evenly spaced, all right? And what does that mean? That means we are going at a constant speed. If you're moving at a constant speed, the force must be balanced. That's right, because an object in motion stays in motion unless acted on by an unbalanced force. If you are moving in a constant motion, there is no unbalanced force. In fact, there's a balanced force. So we check our answer, and I just did 4 of them for you. So if you guys can't get up to 4, I mean, no, you can. I know you can do it. All right, let's go back to the main menu. Boy, if that was that, let's see what wizard level is. 12 questions. No wonder you guys were out here grinding. I gave you like a couple days and a weekend to do it. So let's look at this one here. Oh boy, all together. So it says the object is moving left right now. All right, at least it was moving left at the beginning of the problem. So let me cop this one for us. All right, move that guy over here so I can draw a couple notes and we can have a quick discussion on this. There it goes. All right. Boom. Okay, so we're moving to the left, and if we look at our diagram, what's going on with the forces? Well, you notice this force to the right is bigger than this force to the left, and so our net force is to the right. Guess what, ladies and gentlemen? Newton's second law says you will accelerate in the direction of the net force acting on you. So if we're already moving to the left, but we're accelerating to the right, what that really means is, you know, the force is opposing the way we're going. And if I say, hey, you're moving and a force opposes you, what happens? You would all say, oh, we're going to slow down, right? And obviously just looking at the diagram, you can tell these are unbalanced because the left force is not as big as the right force. So if I go back here, we're moving to the left and we have a net force to the right, so we got to be slowing down, and it's unbalanced. I can tell that just by looking at the picture. So data wet, feeling great, feeling really super validated right now. All right, this one right away. I see Constant dots. What does that mean? Constant speed. Constant speed, balanced forces. Why? The only time you accelerate, guys, is if you're experiencing unbalanced forces. So that's a piece of cake. They're just adding on more questions, aren't they? I should just assign this the last one. Here we got one that's moving to the right, and you notice that the net force is to the right. So if I'm moving to the right and something is pushing on me to the right, then I'm going to speed up. And these are obviously unbalanced forces because there's nothing to counter that rightward force. And so we're just on fire right now. I'll do one more for you guys. Okay, so data. Maybe we haven't done a data one. I'm glad I got a different type here. Let's take a look at this last type of question, and this should get you where you need to be. Remember, guys, the big ideas here are that the net force is going to cause acceleration if it's unbalanced. You're going to accelerate in the direction of the bigger force or the unbalanced force. And then we know what acceleration means. That means changing our velocity. And so we got to kind of put all that together when we come up with our answers. But let's look at this one. All right. We have velocity. Now you notice my velocity changes by 2, and then by 2, and then by 2, and then by 2, and then by 2. But it is changing, right? So my velocity is increasing. Well, this one's easy. Are you speeding up? Well, I don't know. My velocity is increasing, so I guess I'm speeding up, right? And then it says, is it unbalanced or balanced? Well, if you're speeding up, that means you're accelerating. And if you're accelerating, that means the forces are unbalanced. So that one wasn't bad. I didn't really need to write anything for that one. So we're speeding up, unbalanced forces. You have to have unbalanced forces if you're going to speed up. So let's take a look at, I guess I'll give you one more here. All right, let's do this one. You're moving to the left, speeding up, slowing down, or constant speed. Remember the pencil trick? All right, let me just bring this one over here. So I'll wrap up with this one. For this guy, let me cop this over here, move it like this. Can you move it like this? I can shake it like that. That's old school. You guys are probably before your time there. All right, this one we got the if you imagine the slope is not very steep, and then it gets steeper, and it gets steeper, and it gets steeper. Steeper means faster, so that means we're speeding up. All right, and then is the object experiencing balanced or unbalanced forces? Well, if it's a curvy graph, that means we're accelerating, and if we're accelerating, that means the forces are unbalanced. So speeding up, unbalanced. Cop another star. All right, I just need like half of these for you guys, so you should be able to cop the rest of them. This was Mr. Simpkins. Boy, have I missed you last week, but now I'm Super Simpkins. I would never take a sick day ever again, probably, so because I missed you so much. I can't do that again. I can't do that to you guys. So I will be back on, I guess I'll see you for the Zoom day on Tuesday, but please make sure you wrap these up this weekend. And, you know, if it takes you to Monday, tomorrow's an in-service day, right? So if it takes you tomorrow, that's fine. I'm not going to dock you late points. I wish I would have made this video for you sooner, but I saw a lot of messages coming in about this one. So until next time, Mr. Simpkins here in a Simpkins Physics Corner. Happy Sunday evening, and I will see you all soon.